Okay, now that I've installed the library, okay, I can load it. Uh, okay, okay, the random forest actually it's encompassing both bagging and random forest together. Okay, you'll find there's something called M-try. During the lecture, I roughly mentioned normally we have P columns, okay, for our features X, okay, X1 until XP. So in bagging, okay, we will take all of them. So let's see how many columns we have for our data, okay, which is our dimension, right? The car seats data. Okay, the training data, right? Okay, let's look at the. Okay, we have 11 columns. Okay, everyone can see here 11, right? So that's why you are seeing this thing here. Okay, and try equals to 10. So we take the 10 of them to be the training for random forest. Okay, and that would correspond to bagging, because the original bagging algorithm, when it's designed, it takes all the columns. Okay, so this is the model. So the 11 column is the high, which is so-called high sales. Okay, the data is car seats train, and then this is how many columns we are using in the bagging algorithm. Okay, the importance, if you want to ask me, I also don't know. So we just have to put a question mark and ask the documentation. Okay, I hope you still remember this important technique. Okay, during our practical class, I've done this a lot of times. Okay, so let's look at the. So regarding the square root of p and p over 3, this thing in your lecture, the SOA exam, one of it, okay, actually it comes from here, right? Okay, so apparently this is to assess the importance of the predictors, right? Okay, so if this thing is set false, which is by default, okay, the importance of it will not be assessed. Okay, so next is okay, so random forest algorithm basically constructed I don't know how many, okay, probably a lot of random for how should I put it, many decision trees, okay, together, okay, and then they will be voting, okay, and then we want to see what's the improvement on the confusion matrix, okay, by performing prediction. So we again not interested in probability, but just the classification. Okay, and then we construct the confusion matrix for bagging, and is it very much improved? I would think so. Okay, so can I go back? Okay, I cannot. So let's see, we still have some confusion matrix, right? Okay, this is the original one. Okay, I think it's quite obvious that the accuracy is much higher with bagging, okay, compared to the original decision tree. Okay, this is the original decision tree. So now we want to see whether the random forest strategy, which okay, we can choose many values. Okay, apparently here we are choosing 6, so it's like 2/3 of, okay, because 10 of them now we reduce to 6. Okay, randomly choose 6 columns, okay, and with together with the output to generate many different decision trees. Okay, and then ask them to perform voting. Okay, again we want to set the seed. Okay, because during random forest random sampling, okay, we don't want it to be really too random. Okay, so let's try it out and see. Okay, and then see how is our prediction. Okay, compared to the bagging, there seems to be no difference. Shall we try with the value, which is okay, the square root of p, right? Okay, square root of 10 is actually 3, so maybe we want to do it again. Okay, for random forest with the default value, see whether it's nice or not. Okay, let me try 3, right? Okay, 10 either divide by 3 or take square root of 10 divided by 3 or square root of 10 actually gives us 3, right? Okay, so okay, I'll try and see what happens to the okay, is it good? Okay, so this is this part here, I'll highlight it for you, is the random forest with our m to be 6. Okay, here m is changed to 3, and we perform another computation, and apparently it's a bit similar. Okay, but when m is actually lower, you have to remember this, the calculation is going to be slightly faster because we are using less columns in the training. Okay, so apparently accuracy wise, yeah, okay, the m equals to 3 is really much better, right? Okay, so apparently in random forest, okay, you can check on the internet, right? Okay, after training a random forest, it's natural to ask which one of the variables has the most predictive power. Okay, so the importance is associated with measuring, okay, the variable which is actually important. Okay, so that's why you find this part is stated here. Okay, so now we can check the importance of the data, and it tells us what. Okay, it's sorting it for us, and it tells us that the comprise is the most important variable. Okay, that's why you find in the Okay, do we still have the plot? Okay, I think comprise should be at the top level, right? Curious. Oh no. Okay, so apparently is not comprise, right? But who is the most important thing? Shelf location, isn't it? Okay, out of all these measures, apparently okay, this is either this one or the price. Okay, according to the mean decrease accuracy, shelf location is the most important variable. Okay, following the Gini thing, it's price. Okay. So this thing is actually a chart to display who is the most important variable. So who, okay, we can see it's just shelf location and price, right? Okay, so yeah, okay, depending on the measurement. Okay, that's yeah, from the table. Okay, so we'll clear the screen and continue with, I think, probably the last part, right? Okay, the boosting methods. Okay, so have I installed the GBM library? Let's see. Okay, I am installed, so I need to go and install.